Hello and a warm welcome back on this sunny morning in, where are we, January 2024. Bit of a frog in the throat. Anyway, today on the bench is a phono RIAA amplifier, preamplifier Ian has built, and he says it doesn't work. So this is a similar thing that I experienced years and well, decades ago when I first started getting into electronics when I was 16. You'd buy a magazine at that time, you'd probably build it on Vero board, and the bugger don't work, and you can't figure out why. So the first place is to start, I think, having had a bit more experience since then, is to check your work first of all. The preamp kit PCB is basically a PCB, loads of components, you have to put it together and get it to work. And these are the instructions that come with it. This is a Vellerman kit, by the way. I think they've stopped making them. So basically you've just got we've got a list of specifications, a list of the components, and then we've got we've got a list of components, and then you've got a sort of telling you what the various outputs are, and that's it. However, I went online and looked on Phono's website that sell these things, but have only got a stock in America, and there's a bit more information on there telling you when to put in which particular component. To help me to check the board that Ian built, what I've done, this is the layout of the board. I've written next to each component the value that it should be. So now I'm going to go through with a magnifying glass and to check each component. Having built a few things in the past like this, one mistake I did make and have made, you have a, say, 100 ohm, 100k or a 10k resistor. It's easy to get those mixed up. Similarly with any other 2k2, 220 ohm or whatever resistor, but just going by the colour code. So I'll go and check that now, see if he's made any mistakes. I don't think he has after having a quick look at it. But the first rule of diagnosing electronics: check your work, check it again, and check the bugger again. Right, I've been through the whole board, checked every single component with a magnifying glass and put a tick next to them. Because this is a pretty simple board, I am pretty confident that everything is in the right place on top. And as I said before, check, recheck, recheck. I don't feel I need to do this again at this moment, so I'm pretty happy that Ian has constructed the board as per. However, I did find one thing. Right, I hope you can see that. I'm having trouble with the camera focusing, but can you see that black deposit on those op amp legs? Maybe that is causing a problem when it goes into the socket. Is that creating a open circuit when it goes into the socket? We shall find out later. Having had a look at this op amp a bit more, this is really weird, this deposit on these legs. I've never seen a bloody op amp like that. You know, there's a problem with a lot of fakes op amps on the market. I mean, why would anybody fake a 741 op amp? This is supposedly an OPA. I don't know. The writing on it looks decidedly weird. See, you got that. Hold on, let me try and stop waving the bugger about. I've never seen an op amp like this before, with this tarnished legs. I mean, the tarnishing comes off, but look at the writing there. RS741, and then you've got OPA. It's really hard to do this on bloody camera. See that there? That's 78 upside down. As is that. I've never seen a bleeding op amp like that. Is it a fake? I don't know. We shall find out. So what I shall do first of all is to, oh yeah, chuck it on the floor. Try again. What I shall do first of all is to get rid of this tarnishing with this fiberglass pen thing. The op amp is cleaned up, reseated in its socket. The next place to look, because the board has two sides at least, is with the on the underside soldering. I've had a look at this and can't see any problem with shorted traces or anything like that. However, Ian hasn't cleaned up the flux off it, which is a good idea. You don't need anything fancy. I just nicked my daughter's what do you call it, nail remover stuff. So yeah, I used that. So I can't see any shorter turns or anything like that. However, looking at these joints, they're a bit blobby. I think Ian's put a bit too much solder on there, and I think he's got a, well, I know he's got a problem with his iron. His iron should be, I think it should be a little bit hotter. It's always good to have a hot iron, go in quick, do the joint, out. I'm going to put a link to this chap called the Offset Volt. He's got a really amazing channel there, and he's just done a series on how to solder really well. Okay, so I can't really see a problem there. I'll clean that up. And then we've got this here. The only problem I found, hopefully you can see, is where he's joined this wire here. You've got a bit of a few sort of wires. Is that the problem? I don't know. And then we've got like a few wires broken off, but that may be me messing about with the thing. The other thing that, I mean, this is probably not the problem. You see, I've already got a wire broken off there as well. That's probably down to me moving it. I wouldn't have used this sort of screen cable. It's very thick and heavy here, and yeah, the wires are just breaking off. As I said, it's a bit hard to test it with it as it was, because I've knocked a few wires off by manipulating it. So what I'm going to do to make it a little bit simple, these are Ian's ground wires. If you look at the board, you basically got a ground every other one. Instead of running lots of grounds off, what I'm going to do, I'm just going to use one ground, and I'm going to connect up all these grounds together and then just have one wire, just to keep the wire count down and to keep, you know, make it a bit simple. It's also a good idea because you've got less chance, less of a possibility of a ground loop occurring. Okay, before I destroy any of the evidence, Ian's work in other words, we've got number 9 there, sorry, pin 9 or whatever. If you look at my what do you call it, notes, number 9 is out, right. And I did wonder about this when Ian first mentioned it wasn't working. So we've got 9 out, and that is going to right in. This other bloody wires fell off. Yeah, so hang on, and then we've got that one which was going to out, which is pin 7, and according to this, pin 7 is in, right in. So, but I would have thought Ian would have maybe checked that when he was testing the amp. Oh, could I have got the in and outs wrong? In, out, I don't know, possibility anyway. I'm going to tidy all this up to make testing a bit easier, because it's yeah, I've knackered it up a bit. So I've been through, I've unsoldered all Ian's wiring. So you've built something, it doesn't work, you've checked all your work, and as far as you know, it's good. Any electronic circuit or system can be broken down into simpler parts. It's quite hard to deal with something, a massive complex system in the whole. You have to try and chop it into little bits and make sure each individual little bit is working. So in this case, we've got a mains transformer, we've got a power supply, and then we've got the actual board itself. So obviously the first thing I would have done if this had been working was to check that I've got a voltage there on the op amp. Just done it again. The first thing I would have done was to check that we've got voltage on pins 4 and 8. But before we get to that, one thing I have noticed is this is a power supply board that I built ages ago to supply heaters for a Vellerman. I had to send it with the parts all off to Ian to keep the postage costs down. One thing I have noticed is this is an LM317, so it's basically a very simple circuit. Let me get something better to point with than a bloody magnifying glass. Bridge rectifier, smoothing capacitor, LM317 variable voltage regulator, a preset pot, and a couple of resistors. That's it. However, one thing I did notice is that the middle leg, which if I remember right it goes AOI, so the output, the middle leg, will wobble this LM317 about. You can't see it, but the middle leg isn't properly soldered. Whether that's from me mucking about with it, I don't know. But as you can see, you know what I mentioned with Ian's like soldering earlier on, it's a bit blobby. So you see we've got a potential short there. So I'm going to just tidy that up and then we'll crack on. So as I mentioned, check out all your individual parts and then take it from there. Here we are a little bit later. I'm just about to test the mains transformer. I've got it on a variac and a lamp limiter. It's about 240 volts and we've got 14 volts coming out there. So as far as we know, the mains transformer is fine, so we can eliminate that from our inquiries as a source of a possible fault. I've tidied up the power supply board, so to make sure there's no dry joints or dodgy joints or whatever, put a different cap on there. I've also got a big 1K1 resistor as a load. I've got the variac isolation transformer and lamp limiter, one bulb engaged as it were in case we've got a short, and so we're ready to test. One other thing that I haven't mentioned is a method that is sometimes called buzzing out, and all that means is you set your digital multimeter to beep, and so for instance you would test like ground and output, and we haven't got a short circuit there, same as on the input. We've got a short there because that's the secondary of the mains transformer, so we flick on to resistance and we're okay. Next we're just gonna put a bit of voltage into the board. There we go. 16 volts ish, and let me find the screwdriver and see if it's adjustable. Seems to be. Oh, there we go. So it is working. Let me just set that to 15 volts. 15 volts. As far as we know so far, the mains transformer is okay, the power supply is okay. So next I need to wire that up to the preamp board itself and then do some testing from there. So before I connect it to the power supply, I'm just going to check all the grounds and make sure we haven't got a short circuit between the positive and negative terminals, power supply terminals in other words. I've just checked all those out. That's pin 6. We haven't got a short. We've got a resistance of 36k, which is okay. So next I'm going to tack a few little sort of leads on there. So what I do, I collect all my resistor, you know, leads that you clip off, which are really useful for this sort of thing. Just get a few, bend it over with the old pliers, let me solder and get it to stand still. Put a tin it, I'll put some solder on it in other words. There we go. I've got some solder on me iron, so we want this one. This is a ground. There we go. See, hot iron. All you need to do is jump in there, in quick, out quick, a cowboy. And then we need another bit of wire for the positive of the power supply. Put a blob there. See how that's all sort of nice and round. Some of the other ones that, yeah, I don't know. So we'll pop that on there. In quick, out quick. Keep the dwell time down. So next, connect it up to the old power supply. We've got the phono preamplifier in a vise. A couple of bits of cardboard to insulate it from the metal of the vise. We've got it connected to our power supply, and we've got a couple of meters. We've got 1 meter here, which is reading the voltage across the power supply, and then we've got this other meter here, which I'll be using for probing. So let's power it up, and we've got nothing. Right, that's my fault. I've got a lead off. Try again. Very easy to make mistakes. 15 volts. So I'm just going to use my other meter now to make sure that we've got 15 volts ish across the amplifier pins, and this is where you've got to be, and this is where you have to be really careful with this sort of thing. One slip of the probe and you've got dead parts. So pin 4, we've got 1, 2, 3, 4. Pin 4 is the VCC negative, and pin 8 is the VCC positive. So we should have 15 volts there. Let me just pop you up a bit. 15 volts, which is good. And then what I'm going to do, I'm going to probe each individual pin of the op amp. So this is pin 1, which is the output of one op amp, nothing. Pin 2, oops, shite. So you got to watch it, one slip. Pin 2 should be the same on pin 3. pin 2 is your non-inverting, and pin 3 is your inverting input. Whatever I read, they should both be the same. 1.6 volts on one, on pin 2, 1.6 volts on pin 3. That's good. Now I'm going to do the other op amp. It's a bit odd this is without getting in the way of the camera. Pin 5 is a inverting input. Bloody wires everywhere. There we go. Right, there we go again. 2, 3, 4. Pin 5. Okay. I'm reading 0 volts. I would have thought it. Pin 6, 2 volts. Pin 7, which is your output, 1.5 volts. That doesn't seem right to me. That doesn't seem right. Those DC readings don't look right to me. This side, this op amp here, yeah, good. This op amp here, no, I don't think that's right. What we'll do now, we'll put an input in and then we'll read the output, and that will tell us more. We've got wrong DC readings here, we think. So to check whether it's the op amp or something else, all we need to do pull the op amp out and then see if we got the same thing. Here we go then. 15 volts, everything's cushy. Okay, we were getting odd readings here, weren't we? That's your non-inverting. I'm getting 7 volts there, 7 volts there, 0 volts there. I think this op amp is dead. One of the op amps inside this is dead, the right hand side one. We'll find that out when we do some AC tests. Here we are another day. I've been checked out, everything, power supply, blah de blah de blah. I've swapped this, if you look in whatever it is, 741 op amp for a TL072. We've got DC going in, and as you can see, I hope you can see anyway, we've got a really nice stonking output. Oh god blimey, what is that? Where are we? 1 volt per div. 1, 2, 3, 4, 5, 6 volt peak to peak. I don't know, maybe that's what, about 3 volts or something like that, or RMS, not sure. However, when I put, that's on the left channel, and where's me, so I've got that many probes and bloody bits and bobs here. Put that on the right channel, we've got sweet FA, so we've still got a problem. So we'll stop saying so. It's really odd making these bloody videos, you know. If you're not careful, you end up like saying the same old crap all the time. Anyway, I suspect we've got some iffy soldering on the bottom there. When I first examined this board, which is really odd to do when this is on Zoom. Right, when I examined this board, see here, there's like a scoring across here. This is the right hand channel, because we're spun 180 degrees, you with me? And I think what Ian has done is cut across here with a scalpel or something, because he thought he'd shorted out this and this joint. I'll show you the circuit in a minute. You got where are we? We've got the input down here, goes through a cat to here, and then goes into the op amp here. We should have continuity, I think, between there and here. We don't. So I think if I bridge that, we should get the right channel back. Let me go and check. So this goes back to checking your work. You can use some basic tools to diagnose any circuit. If you haven't got an output, then check the input. So here's our input. We know that goes through this capacitor. Over here, we haven't got continuity. I'm going to tidy all this up a bit, re-establish that trace there, and then we'll test it again, see what the crack is. I'm having to film this on wobble cam because we've still got the right hand channel is working. However, we've got a problem, I think, with this op amp socket. Sometimes I touch it and we're getting a signal. Oops. And sometimes not. So I need to address this before I go any further. Well, I hope that gave you a few ideas about how to find faults with your own builds, your own circuits, your own projects. A few little tips there. We've still got a bit of a ways to go. We've found out why it wasn't working. I've still got a few little bits and bobs to get it working completely, and as you see it here. Thank you all for sticking through this so far. Part 2 will be along soon. Thanks very much for watching. Ta-da for now.